The surface of Mars is renowned for its aridity. The entire planet is a dusty, barren desert, a wasteland of rock and, in some regions, ice. But of liquid water, not a confirmed drop has been found. Recently, scientists unveiled a bombshell discovery. They'd found evidence of a colossal underground reservoir of liquid water at the Martian South Pole. Now they've taken that discovery a crucial step forward. There's not one, but an entire network of multiple lakes under the southern polar ice cap. Let's take a closer look at this amazing discovery. While scientists believe that liquid water may still flow on Mars, that doesn't mean it's easy to spot. The search for water on the red planet has taken more than 15 years to turn up definitive signs that liquid flows on the surface today. In the past, however, rivers and oceans may have covered the land. This begs the question of where did all of the liquid water go and how much of it remains. Liquid water appears to flow from some steep, relatively warm slopes on the Martian surface. Features known as recurring slope lineae were first identified in 2011 in images taken by the high-resolution imaging science experiment camera aboard the Mars Reconnaissance Orbiter. The dark streaks, which appear seasonally, were confirmed to be signs of salty water running on the surface of the planet. In 2015, spectral analysis of RSL led scientists to conclude they are caused by salty liquid water. Scientists believe that the detection of hydrated salts on these slopes means that water plays a vital role in the formation of these streaks. Vast deposits of water appear to be trapped within the ice caps at the north and south poles of the planet. Each summer, as temperatures increase, the caps shrink slightly as their contents skip straight from solid to gas form, but in the winter, cooler temperatures cause them to grow to latitudes as low as 45 degrees, or halfway to the equator. The caps are an average of 2 miles thick and, if completely melted, could cover the Martian surface with about 18 feet of water. Frozen water also lies beneath the surface. Scientists discovered a slab of ice as large as California and Texas combined in the region between the equator and north pole of the red planet. The presence of subsurface water has long been suspected, but required the appearance of strange layered craters to confirm. Other regions of the planet may contain frozen water as well. Some high-latitude regions seem to boast patterned ground shapes that may have formed as permafrost and the soil freezes and thaws over time. The European Space Agency's Mars Express spacecraft captured images of sheets of ice in the cooler, shadowed bottoms of craters, which suggests that liquid water can pool under appropriate conditions. Other craters identified by NASA's Mars Reconnaissance Orbiter show similar pooling. Evidence for water on Mars first came to light in 2000 with the appearance of gullies that suggested a liquid origin. Their formation has been hotly debated over the ensuing years, but not everyone thinks that Mars contains water today. New research reveals that RSL may have formed by granular flows formed by the movement of sand and dust. However, that may all change thanks to the recent discovery of a possible subsurface lake near the Martian South Pole. Researchers made a big splash when they announced that Mars might be hiding a lake beneath its southern pole. The European Mars Express spacecraft used its Mars Advanced Radar for subsurface and ionosphere sounding to detect the proposed water. Ground-penetrating radar sent radar pulses to the surface, then timed how long it took for them to be reflected. The properties of the subsurface layers affect how long it takes for the beams to return. Mars's investigation revealed that the Martian South Pole is composed of multiple layers of ice and dust in a depth of about nearly 1 mile spread over a 124-mile-wide region. Scientists say that this subsurface anomaly on Mars had radar properties matching water on water-rich sediments. Marsis also revealed the presence of a subsurface lake among the pockets. According to the radar echoes, the lake is no more than 12.5 miles across, buried nearly a mile beneath the surface. Scientists aren't certain of the lake's depth, but they have confirmed that it is at least 3 feet deep. According to the researchers, the lake must have salt to keep it from freezing. This is just one small study area. It is an exciting prospect to think that there could be more of these underground pockets of water elsewhere yet to be discovered. Not all researchers are as certain about the presence of liquid water. There's always the possibility that conditions that we haven't foreseen exist at the base of the cap and are responsible for this bright reflection. The idea that Mars could harbor liquid water beneath its polar caps in the same way that Earth does was first proposed more than 3 decades ago. On Earth, lakes beneath the Antarctic and Greenland ice sheets are created when heat from within the planet melts the glaciers in patches. Scientists hypothesize that a similar scenario could happen beneath the Martian polar ice caps. The bright spot seen in the Marsis data is an unusual feature and extremely intriguing, and researchers hope to use other instruments to study it further in the future. When Mariner 9 became the first craft to orbit another planet in 1971, the photographs it returned of dry riverbeds and canyons seemed to indicate that water had once existed on the Martian surface. Images from the Viking orbiters only strengthened the idea that many of the landforms may have been created by running water. Data from the Viking landers pointed to the presence of water beneath the surface, but the experiments were deemed inconclusive. The early 90s kicked off a slew of Mars missions. Scientists were flooded with a wealth of information about Mars. 3 NASA orbiters and 1 sent by the European Space Agency studied the planet from above, mapping the surface and analyzing the minerals below. Some detected the presence of minerals, indicating the presence of water. Other data measured enough subsurface ice to fill Lake Michigan twice. They found evidence that ancient hot springs once existed on the surface and sustained precipitation once fell in some areas. And they found patches of ice within some of the deeper craters. Impact craters offer a view of the interior of the red planet. Using the ESA's Mars Express and NASA's Mars Reconnaissance Orbiter, scientists were able to study rocks ejected from the planet's interior, finding materials that suggested the presence of water. But orbiters weren't the only objects launched towards Mars. NASA's Curiosity rover is the 5th robot to land on the surface of the red planet in the last 15 years. Pathfinder, Phoenix, Spirit, and Opportunity all took detailed measurements of the planet. All but Phoenix traveled across the surface collecting a treasure trove of information. The probes dug into the ground, examining rocks and performing experiments. In 2008, Phoenix turned up small chunks of bright material that disappeared after 4 days, leading scientists to surmise that they were pieces of water ice. The lander went on to detect water vapor in a sample it collected and analyzed, confirming the presence of frozen water on the red planet. Spirit and Opportunity, the twin rovers, found traces of water enclosed in rock. In a shining example of a problem becoming a solution, a broken wheel on Spirit scraped into the top of the Martian surface, revealing a layer beneath rich in silica that had most likely formed in the presence of water. Over the years, Curiosity has found yet more evidence of water flowing on ancient Mars. The One-Ton rover rolled through an ancient stream bed shortly after touching down in August 2012, and it examined several rocks that were exposed to liquid water billions of years ago. Mars missions aren't the only way to search for water on Mars. Scientists studying rocks ejected from the red planet found signs that water lay beneath the surface in the past. While robotic missions to Mars continue to shed light on the planet's history, the only samples from Mars available for study on Earth are Martian meteorites. These samples allow scientists to utilize multiple analytical techniques to take a more in-depth look at meteorites and shed light on the history of Mars. In addition to examining the relatively recent presence of water, the various missions have also studied the surface of the planet in a historical context. The riverbeds of Mars don't run wet today, but scientists can study them to learn more about the evolution of the planet. The flatter northern plains of Mars may once have hosted an ocean, or possibly as the planet cycled through dry periods. According to scientists, the more recent body of water would likely have only been temporary, seeping into the ground, evaporating, or freezing in less than 1 million years. Riverbeds and gullies indicate that water ran, at least briefly, across the surface of Mars. According to estimates, 100 times more water may have flowed annually through a large channel system known as the Marte Vallis, then passes through the Mississippi River each year. The gullies themselves are smaller, likely forming during brief torrential rainstorms when fast-moving water could have carved them from across the land. Curiosity found indications that at least one region of Mars, Mount Sharp, was built by sediments deposited in a lake bed millions of years ago, suggesting large pools existed on the planet for significant periods. If this hypothesis for Mount Sharp holds up, it challenges the notion that warm and wet conditions were transient, local, or only underground on Mars. On Earth, the land around rivers and lakes is wetter, made up of mud and clays. Such deposits exist on Mars as well, trapping water and indicating where larger bodies may have once existed. Water on Mars may be doing something more than sitting pretty. A new study reveals that when the liquid boils, thanks to low pressures, it can make the sand levitate. The research states that sediment levitation must therefore be considered when evaluating the formation of recent and present-day Martian mass wasting features, as much less water may be required to form such features than previously thought. Water may seem like a very common element to those of us stuck on Earth, but it has great value. In addition to understanding how Mars may have changed and developed over time, scientists hope that finding water will help them to find something even more valuable: life, either past or present. Only Earth is known to host life, and life on our planet requires water. Though life could conceivably evolve without relying on this precious liquid, scientists can only work with what they know. Thus, they hope that locating water on celestial bodies such as Mars will lead to finding evidence for life. With this in mind, NASA developed a strategy for exploring the red planet that takes as its mantra, "Follow the water." Recent orbiters, landers, and rovers sent to Mars were designed to search for water rather than life, in the hopes of finding environments where life could have thrived. That has changed, however, with the flood of evidence these robots have returned. Curiosity determined that Mars could indeed have supported microbial life in the ancient past, and the Perseverance rover is already hard at work collecting even more data for the study. If you enjoyed this video, please also check out this one, which talks about the Perseverance rover and its new mission to find life on Mars. Do you think Mars has liquid water under its surface? Please share your thoughts in the comments section below.